What's up, people? We're about to puzzle some more stoichiometry here. I'm going to spell it right today. Stoichiometry. Look at that T I got in there this time. Stoichiometry. All right. Now, in this equation, we drop some solid lithium into some aqueous magnesium sulfate, and we end up with aqueous lithium sulfate and solid magnesium. Yeah, yes, this would fizzle when it hits the water, but let's just do this, all right? Give me a break. All right, let's balance it. I'm going to get a 2 there, and I think that's it. 2, 1, 1, 1. All right? So it's balanced. Now, let me ask you a question. How about this? We're going to go old school. We're going to go easy from yesterday. 3 moles of lithium could produce blank moles of magnesium. All right. And here we go. How do we do this? Well, 3 moles of lithium. Well, in our original equation, it says 2 moles of lithium and 1 mole of magnesium sulfate yield 1 mole of lithium sulfate and 1 mole of magnesium. So if instead we had 3 moles of lithium, how many moles of magnesium would we have? All right, so we're going to say 3 is to 2 as x is to 1. And that answer would be a 1.5 moles. Let's do another one. Now see, this is the same equation, all right? But I'm going to change this a little bit. I'm going to change the problem just a little bit. What if I said 3 moles of lithium could produce blank grams of magnesium? Blank grams, all right? We're going to say 3 moles of lithium. Where am I going to put that 3? Over which one of these? That's right, we're going to put the 3 here. 3 moles of lithium, 3 is to 2, blank grams of magnesium. So first, we need to find out how much magnesium is going to be made. 3 is to 2 as x is to 1. 3 over 2 equals x over 1. 1.5 moles, just like the last problem. But this time I said 3 moles of lithium could produce blank grams. Well, this is how simple that is. You solve for your moles first. 1.5 moles of magnesium. Well, how much does a mole of magnesium weigh? 24 grams. Okay. 1.5 times 24, 36 grams. Pretty simple, right? Let's try another one. All right, what are our balance numbers for this problem? What are our balance numbers for this problem? Got 2 OHs there. Got 2 chlorines. 2, 1, 2, 1. All right, let's come up with a problem for this. All right, here's our problem. 5 moles of sodium hydroxide could produce blank grams of calcium hydroxide, all right? 5 moles of sodium hydroxide. So where am I going to put that 5? Okay, that's where I'm going to put it right here. 5 is to 2. And then could produce blank grams of calcium hydroxide. 5 is to 2 as x is to 1, because we have to solve for moles first. 5 is to 2 as x is to 1. 5 over 2 equals x over 1. That's going to give me 2.5 moles of calcium hydroxide. Right? 2.5 is the number that would go there. All righty. So how many grams would that be? That's right. 2.5 times the weight of calcium hydroxide. CaOH2. Let's see, OH, that's 17 times 2 is 34. That's about 74 grams there. So 2.5 times 74 equals 185 grams or thereabouts. We're rounding off a lot. All right, let's try another one. Okay, here's an equation I can ask you about. Before I even ask you any questions, I need you to balance this. So what are the balance numbers? That's right, it's 1, 2, 1, 2. All right, now this one's worded a little bit differently. How many grams of MgCl2 are needed to produce 5 moles of the precipitate right here, 5 moles of lead-1 chloride? How many grams of MgCl2 are needed to produce 5 moles of PbCl? Okay, obviously, we can put this 5 moles. Where can we put that 5? That's right. 5 over 2. It says how many grams of MgCl2? So we're asked about MgCl2. So x over 1 equals 5 over 2, right? Now, when we solve for this x, are we going to be getting grams? No, we're going to be getting another unit, and that unit is moles. So check this out. X over 1, I got that from right here, equals 5 over 2. So x is equal to 2.5 moles. And the question says how many grams of MgCl2? So if we have 2.5 moles of MgCl2, how many grams would that weigh? All right, first we got to find out MgCl2 and how much that weighs. That's going to be 24 plus 70, so that's going to weigh 94. So up here, 2.5 moles times 94 grams per mole. Take my calculator. 2.5 times 94 equals 235 grams. 235 grams of MgCl2 are needed to produce 5 moles of lead-1 chloride. Now, I want you to notice, every time these fractions, the numbers are always stand for what units? The fraction here and here, these numbers always stand for what units? That's right, they always stand for moles. And then you have to convert once you know your numbers. Let's try another one. All right, here's a new question. It's harder, all right? We're going to have to convert twice. How many molecules of H2 are produced using 25 grams of magnesium? Now, the first thing we have to do is balance, so what are the balance numbers? That's right, it's 1, 2, 1, 1. And now here we go. I'm going to ask you a question. What do these numbers stand for? What units? Okay, right, those stand for moles. So the first thing, how many molecules of H2 are produced using 25 grams of magnesium? So we have to convert 25 grams of magnesium to moles. That's the first thing we have to do. So I'm going to say 25 grams over 1 times 1 over, how much does magnesium weigh per mole? 24 grams. So that's going to give us 25 divided by 24, 1.04 moles. So we have 1.04 moles. So now I can put that here because these numbers in the equation stand for moles. 1.04 is to 1 as how many molecules of H2? I'm going to put an X over there. 1.04 is to 1 as X is to 1. Guess what? We're going to produce 1.04. That X is going to be 1.04 moles of H2. But the question says, how many molecules of H2? How are we going to convert 1.04 moles to molecules? How are we going to do that? We're going to say 1.04 times 6.02 times 10 to the 23rd. It's that simple. times 6.02 EE23 equals 6.27 times 10 to the 23rd. That's how many molecules you're going to have of H2. So once again, whatever numbers you're given, convert them to moles, then do your fraction. And then if they ask you for something different, then convert your new answer into the new numbers. It's really straightforward. See how much time we're 10 minutes into this. Let's do one more of these. Here's an equation. We take lithium solid and we drop it into water. It's going to make lithium hydroxide and hydrogen gas. What are our balance numbers here? Okay, our balance numbers are 2, 2, 2, 1. All right, now I'm going to ask you a question about this. Here's the question. 7 grams of lithium are dropped into the water. If you did that, if you dropped 7 grams of lithium into the water, you could produce blank molecules of H2 gas, all right? So we're dealing with these two right here, okay? Now, I can't put 7 grams here. I have to convert 7 grams. What do I need to convert it to? That's right, moles. So let's see, 7 grams of lithium over 1 times 1 over the proper number. Well, guess what the proper number is for lithium? 7 grams. So that's 1 mole. That worked out real easily, didn't it? So 1 mole of lithium could produce X of hydrogen gas. 1 is to 2 as X is to 1. So we have to solve for moles first. So how many moles of hydrogen gas would that be? 1 over 2 equals X over 1. I'll just write it up here. 1 over 2 equals X over 1. So how many moles is that? 0.5 moles. So 1 is to 2, as 0.5 is to 1. So we can make 0.5 moles of hydrogen gas. But the question said, how many molecules? How are we going to convert 0.5 moles to molecules? Well, that means half of the number of molecules. 0.5 times 6.02 times 10 to the 23rd. That's going to give us 3.1 times 10 to the 23rd molecules of hydrogen gas. That's it. That's the secret. That's how you do it. Good luck.